Hello students and welcome to another algebra lesson. This time we are going to explore how we can use matrices to solve systems of linear equations. To begin, we need to ask ourselves, what is a matrix? It is not the movie. A matrix is an arrangement, it's an array of numbers, and it's usually in a rectangular shape or a square shape. It can be either numbers or variables, like that. Matrix may also, because they are number, they might be fractions or decimals, right? So we put things into a matrix so that the computer or the calculator can do operations for us really fast, especially when we deal with a lot of data, right? And the human capacity can only do so much, but the computer can do them really fast. So we put them into a matrix, and we tell the computer to do operations like add, subtract, and multiply, and that kind of stuff, right? So today we're going to take a look at how we're going to use matrices to solve systems, right? So we use what we call an augmented matrix when it comes to linear equations, because we have to arrange these numbers in a certain way, right? So the augmented matrix, by definition, is it's a coefficient matrix plus the constant matrix, right? So in combination, it's going to be called the augmented matrix. We write both of them together, right? So because of the system of linear equations, we have the variables, and then we have the constant on the other side, right? Like the standard form, right? So when we write the system in standard form, we have all the variables on one side with the coefficients and all the numbers or the constants on the other side, right? So we want to write an augmented matrix so we can put all of these numbers into one matrix so that we can do some operations, right? So it's going to look like this. So here's a system. You have 2x plus 3y minus 2z equals to 8. And then you have x minus 4z equals to 1. Notice the second equation is missing the y variable, right? So it's 0y. There's no y, right? And then the last equation is 2x minus y minus 6z equals to 4. As you can see, each equation has three variables, well, except for the second one. So this is what we consider a three equations with three unknowns, right? We have x, y, and z, and we don't know what they are, right? We're supposed to find them. Um, so the first thing is we have to arrange them in standard form, which they are, okay? And then we're going to arrange them in what we call an augmented matrix. So we're going to combine. So as you can see here, the coefficient matrix is the matrix that takes all of the coefficient of x, y, and z and arrange them into a 3 by 3 matrix. This is a square matrix. It has three rows and three columns, right? Now notice the middle value is 0, and that 0 is to take place of the y that is missing here, okay? Because there's no y variable, so we have to put a 0 in its place. 0 is a placeholder, remember? And then finally, the third equation, we have 2, and then the -1 and -6, which are the coefficients. So we call this the coefficient matrix, right? And then over here, we have the variable matrix, which means we take all the variable x, y, z that we don't know, we multiply by this coefficient matrix, and then all of that is equal to the constant matrix, which are these numbers right here, 8, 1, and 4, right? So it's pretty straightforward. We put these matrices together, and we get an augmented matrix, okay? So the augmented matrix, it's get rid of this variable matrix and take the constant matrix and put it, I'm sorry, I skipped too fast. Take the constant matrix and put it back within the coefficient matrix, okay? So as you can see, you take this column and put it in and make an extra column for this 3 by 3. So now you have 3 rows and 4 columns. One of the column is for the constants, right? So that's pretty straightforward, okay? And that's how we're going to make an augmented matrix. Every time you want to solve a system of linear equations by matrices, you have to make an augmented matrix, okay? So let's take an example, okay? So here's you have three equations. with apparently three unknowns because we have x, we have y, and then we have z. The first equation, we have x and y, but no z. The second equation, we have no y. And then the third equation, we have all of them, right? We have x, y, and z. So how do we write this in an augmented matrix? Remember, the augmented matrix, to make things look easier when you make the augmented matrix, I want to expand this and put 0 into place of where there's no variable. So let's look at the first equation. There is no z, so I put a 0z there, right? Now, you don't have to do this step every single time because eventually you're going to get very used to it, because you go in order and you're like, oh, there's that one's missing, so put a 0 in there, right? So it's going to be very intuitive once you have done it a few times, right? So, and then we go and we just take the numbers and we put them into what we call a matrix. So the first row of numbers represent your equation 1, right? And then so on, equation 2, and then equation 3. And then each of these are representing your all of your x coefficients, all of your y coefficients, all of your z coefficient, and then the constants, right? So each column has their own representations, okay? So this is considered a 3 by 4. It should be four columns, right? This is 3 rows, and I made a little mistake there. Oh, I didn't make a mistake here. So this is a 3 by 4 matrix C, right? Because we have 3 rows and 4 columns, not 5 columns. Sorry about that, guys. I'm going to fix it next time. So here's an example. I just want you guys to practice really quick. So as you can see, the first row, let's just talk about the first row when you write an augmented matrix. What is it going to be? So take a minute to think there, or a second to think there. Look at the second row. If you make a matrix, what would the numbers look like, right? And then look at the third row. Is there anything missing? And if it's missing, what do you put in place, right? So talk about that. Think about those kind of things, okay? So that you don't have to rewrite this equation and put zeros in there, right? So the first row should be, looks to me like 1, 3, and -1, and then 2. 1, 3, -1, and 2. Okay, the second row for my second equation would be 4, 2, 5, and then 1. 4, 2, 5, and then 1. My third row, now notice the x has a variable of coefficient of 3, but the y doesn't have, the y is not there. So the coefficient for the y is actually 0, and then the coefficient for z is 1, and then the constant is 12. So this right here, guys, is called the augmented matrix. Okay, now the next question is, how do we use the calculator or the computer to help us solve these systems once we have written the augmented matrix, right? So the augmented matrix we have to do ourselves, right? The computer can't do that, right? So it's human, right? The human does it, right? So there is a what we call the row reduced echelon form. Now I'm not going to go into detail what it is really and how what the math behind it is. It's just this is one of the functions that your calculator or your computer is going to be using to find the solutions for you, right? It is called row reduced echelon form. So it does a lot of math, and it messing up with your original matrix, and it does something, and then it's gonna look a certain way so that you know that, oh, we got the solutions, right? So it's called reducing the row, right? um, so RREF is the short hand for row reduced echelon form. It is a method used by the computer, right? So if you want to know more about this method, you could go into linear algebra later in college, and then you can learn more about it, right? You can enjoy doing all of these by hands. Anyway, so it's going to look like this. Once your computer or your calculator has finished calculating, it's going to look like this. So the diagonals from left to right going downward, it's all going to be 1. Everything is going to be zeros except for your last column, because your last column is actually your solution column, right? So this is the augmented matrix after it's been reduced, okay? So notice that diagonal is all 1, okay? And then there, that last column are actually your solutions column, okay? So let's review really quick, okay? To solve linear systems by matrices, you first have to take the system and write the augmented matrix using the coefficients and the constants, right? So humans does this step, right? We do this step. And then the next thing is the calculator is going to take all of that information, all of that numbers, and it's going to perform a whole bunch of operations really fast behind your back. You won't even see it. And then it's performing row reduction, right? So it finally ends up with what we call row reduced echelon form. Okay, RREF. That's the function that you're going to be pressing in your calculator, and I'm going to show you how to do that in just a second. Um, and then after it's finished doing that, it's going to give you the solutions, right? It's going to give you the solutions with all the corresponding values for your x, your y, and your z. Now, we have to be able to look at the answers and say, oh, this is my x value, this is my z value, this value could be anything, right? Because sometimes a variable could take any number, right? Like it's our real solution. So you have to be able to interpret what the answer means, right? So humans does that step also, right? So once the calculator finish all the calculation and it gives you an answer, you have to look at the answer and be able to say, oh, x is equal to blah blah blah, y is equal to blah blah blah. So that's human. We do that step, right? And then we write the solution. So of course we do that step too, right? Okay, so pretty simple. The calculator does all the operations. We just need to know what to put in and what it means when it comes out. Okay, so let's talk about that previous example that we just did. Okay, so we put this system into augmented matrix. So now I'm going to show you how to take this augmented matrix, put it in your TI calculator, and then do row reduced echelon form, and then get the solutions. Okay, so let's talk about that. So the first thing you want to do after you have already put the system into the augmented matrix, which we did, um, you're going to first turn on your calculator. You notice there's a little button down here, the button where it says inverse. There's a word that says matrix here. Whenever it's blue, it means we have to press second and then inverse. So for matrix, so I press second, matrix. And now it gives me a whole bunch of matrices here. None of them has been made yet, right? So I want to go to edit so I can enter a new matrix, right? So I want to edit the first matrix because just first in on the list. So I hit enter, and then it asks me for the size of the matrix, right? This matrix, if you look over here, our matrix has 3 rows and 4 columns. So we're going to put 3 by, move over by 4, okay? And then you can hit enter to move into your matrices so you can enter these values. Now, the values you enter is going to go in order by row, okay? Not by column, by row. So if you hit 1, enter, it will jump to the next space on your row, okay? So it's going to be 1, enter, and then 3, enter. Notice it moves to the right? And then -1, enter, and then 2, enter. And then it moves down to your second row. So the first column will be 4, enter, 2, enter, 5, enter. And make sure you check along the way. 1, enter. Data entry is very important, guys. 3, okay, I just moved my calculator. Hang on. 3, enter. Sorry about that. 0, enter. 1, enter. And then 12, enter. Okay, now that you have your matrix already entered, what you want to do now is you want to tell the calculator to do some math, right? So what you want to do is you want to go back to your your main menu, so or your main screen, your home screen. So second mode to get out of that, right? Now we want to perform some math. So we want to go back to the matrix, so second matrix. And now we don't want to edit, we want to actually do some math. So move to the second column, the middle one right there. And here's a whole bunch of functions what the matrix what the calculator can do with your matrix. What we want is the RREF, right? RREF. Make sure you have 2 R's, right? RREF. And then you hit enter, and then it's going to ask you in this space, which matrix do you want me to calculate, right? Or to do row reduce. So you want to go back to matrix, second matrix, and then you hit under names, you select matrix A, which is the one we just built, right? So you just hit enter, or you can press 1, and then I close the parentheses, and then I hit enter again. So there it is right here. As you can see, the rows, the diagonals are all ones, and then the last column is 5, -2, and then -3. This corresponds to your answers. So the first, notice the first one, that's your x variable. So this means x is equal to 5. And then the second column, second row, this is 1 right here, represent your y variable in that order, right? So y equals -2. And then subsequently z equals -3, right? So these values over here are your actual solution. So as you can see, with one press of the button, the matrix can solve the systems for you. So going back to our system, the solutions that we have for this, this is 5, -2, and then -3. We put them in all into in order like that. Or you can separate them and say x equals 5, y equals -2, and z equals to -3. Now, next thing I'm going to show you is I'm going to show you how to take this. If you don't have a TI calculator, I'm going to show you how to use the online version and still do the same thing and still be able to get your answer, okay? So here I want to show you, if you don't have a TI calculator, how to use the online tool to find your row reduced echelon for your matrix. Okay, so you can solve your systems. So if you want to click here, if you go to my one pager for resources, you can click here. It will take you to the link where the calculator is. You just click that and it's going to take you here. And the first thing it's going to ask you, internet's a little slow. The first thing it's going to ask you is the size of your matrix, right? So let's take this example for our demonstration. So we have RST, so 3 variables, right? So our matrix is going to have 3 rows. So because we have 3 equations and 4 columns, right? The last column is your constant column. So we're going to put these values in. So we want to tell the computer to give me 1, 2, 3 rows and 1, 2, 3, 4 columns. And then you hit create matrix so that it gives you the cells so you can enter the cells. I don't know why that keep popping up. So here are your 3 rows and columns. So I'm going to enter -6. So you can just type it in, move over. 5 is my next value for my S coefficient, and then 2 for my T coefficient. And then the last one is the -1, -11, I mean, for my constant. Moving down to the next equation, the first is -2. And then we have S by itself, which means the coefficient is 1. And then T, 4T, so coefficient is 4, and then a -9, right? So I'm using a different example to show you how to do this. So next one, my last equation is 4R, so the coefficient is 4. The -5s. Now be careful, when it's minus, you have to put the negative sign in, okay? So it's -5, and then plus 5t, so it's +5, and then the coefficient, I mean the constant is -4. So once you do this, conveniently this calculator is just to it's built for the row reduced echelon form, right? So you can just hit that, and then down here, it gives you the row reduced echelon form. And our answer is not very nice, but if you can see, these numbers are getting very close to 4, 3, and -1. So I bet you our solutions are x, or in this case is r. R would equal to 4, s would equal to 3, and t would equal to -1. So this is another option you can use. Excuse me, if you don't have the TI calculator. Okay, see you guys next time, and thank you for watching.